Assalamu alaikum wa rahmatullahi wa barakatuh. Let's start with our lesson today, motion in one direction. Learning outcomes. Identify the concept of motion and its types. Identify the concepts of speed, relative speed and average speed. Calculate the speed, average speed and relative speed of moving object. Compare between speed and velocity according to their type of physical quantity. Acquire mental skills to solve problems on laws of motion. Let's start by this picture. It's a picture for a baby lying on the ground. Okay, it means it is in rest position. When someone is doing nothing or lying in bed, we can say an object is at rest. When the position of an object doesn't change with time with respect to its surrounding, this means this object is at rest. Okay, let us looking at this picture. The baby is walking on the ground. The horse is running on the ground. The car is in the racing. The train is in the railway station. This means all object can make change in its position, so we can call it make a motion. Motion means is changing the body position as time passes according to the location of other objects. We have different types of motion. Let's remember it. We studied it before. We have the first one. Motion can be broadly classified into two main categories. Number one, transitional motion. The second one, periodic motion. Let's discuss the first one, transitional motion. Like the apple falls on the ground is the motion of a body between starting point and an ending point. The second one, periodic motion. Periodic motion means it is the motion that is repeated regularly in equal intervals of time. We have examples here like the oscillatory or oscillating spring and the motion of planets around the sun. Okay. Linear motion. When the ball moves from the first point to the last one, it means it moves in a straight or linear line. Okay, it make a change in position or make a motion. A body moving in a straight line is said to be in a linear motion, like an ant on a wire. Okay, let us discuss some examples or some exercise about it. What type of motion is this? Look at the picture. It's the earth rotating around the sun. Okay, we have the first one, periodic. The second one, curvilinear. The third one, translatory motion. And the last one, circulatory motion. Okay. The answer is translatory motion. Okay. It means it can change its position. Okay, this is motion. What type of this body? The first one, oscillatory, periodic, curvilinear, and rectilinear. The answer is oscillatory motion. It means it can repeat itself in equal intervals of time. And we have the clock kind of motion, translatory, periodic, oscillatory, and circulatory. We have here periodic motion. It can repeat itself in equal intervals of time. Let us see this picture. We have the car here making a motion in crowded street. Okay. So it take a time to change its position. It can make a speed. Some cars can move with a high speed and other cars can move with low speed. So speed is a physical quantity which is used to describe and compare the motion of object. Speed, it is the distance moved through a unit time, or it is the rate of change of distance. Here we have car move from the start point, it take a time 5 seconds, and the red car take 10 seconds. Okay, they move the same distance 100 meter. Okay, so the yellow car is faster than the red car because it take a shorter time span than the red car to cover the same distance. We have an example. Here we have the yellow car moves 100 meter and the red car move 50 meter. Each one take 5 seconds. So the yellow car is faster than the red car because it covers a longer distance than the red car at the same time span. Speed or scalar quantity. We have taken that we have two types of physical quantity, scalar and vector. Scalar, it means we have magnitude only to describe it, and another one vector, it needs magnitude and direction to describe it. We have speed here is a scalar quantity only, so we need magnitude only to describe it. Okay, factors affecting the speed of object. Let's discuss. We have here two factors. The first one is distance. We have the car A and car B. Car A move a distance 10 meter, car B move a distance 20 meter. They take the same time. So car A is slower and car B is faster as it covers longer distance in the same time. So as the time increase, the speed will decrease. Distance is directly proportional to the speed at constant time. Distance is directly proportional to the speed at. Okay, we have the second factor here, time. Okay, we have here car A and car B. Car A take a time less than car B. Sorry, car A take a shorter time and car B take a longer time. So car B is slower than car A to cover the same distance. The second factor here, the time is inversely proportional to the speed at constant distance. We have here two factors affecting the object speed. The first one, distance is directly proportional. So as the distance increases, the speed will increase. And time is inversely proportional. As time decreases, the speed will be increases. Okay, so as time decreases, speed increases. We have here some conversion of some measuring units for the speed. The first one we have distance and the second one we have time. So conversion of distance measuring unit, here we have the length. We have the biggest one here meter, and bigger than it kilometer. So we can change from kilometer to meter times 1000, from meter to centimeter times 100, from centimeter to millimeter times 10. From the smallest to the biggest we can divide, vice versa. Means we can make a divide to change from smallest to the biggest one. From the smallest here, meter to kilometer, divided 1000. From centimeter to meter, divided 100. From millimeter to centimeter, divided 10. The second one here, we have conversion of time measuring unit. We have hour, less than 8 minute, and less than 8 second. Okay, we can change from hour to second, 2 minute times 60, and from minute to second times 60. Also we can change from second to minute divided 60, and from minute to hours divided 60. Okay, we have here the law to describe the speed. Okay, speed, we have two factors describe it, distance and time. Okay, we have here speed, take the symbol v and distance takes the symbol d, and time takes the symbol t. So we have here distance divided time means it is the law for describing the speed. This means that distance is directly proportional to speed and time is inversely proportional to speed. From this relation we can calculate distance by making distance here equal velocity or speed v time time, and we can calculate time equal v time d. Okay, the measuring units of speed. Here we have the measuring unit of speed. We mean that we take the rule distance over time. So distance, if we have distance in meter, we have the time in second. So the unit of measuring speed is meter per second. The other one, distance means meter and time minute. So the speed meter per minute, kilometer and time hour. So we have speed kilometer per hour. If we take kilometer in distance and the time second, we have here speed kilometer per second. Okay, how to convert between meter per second to kilometer per hour? We have here 1 kilometer per hour. Okay, if we have taken before that kilometer equal 1000 meter, and hour, to change from hour to second, we have here 60 times 60. So we will calculate it. We have here 1 meter per second equal 3.6 kilometer per hour. So to convert from meter per second to kilometer per hour, multiplying by 3.6 or multiplying by 1000 divided 60 times 60. Okay, the same answer. They are the same answer. So to convert from kilometer per hour, the biggest one to the smallest one, divided by 3.86. Okay, and vice versa. We have here video to remember all that we take about speed. We have here some problems about the law of speed. If we have a car covered a distance 150 kilometer in 1.5 hours, then it covers the following 180 kilometer in 2 hours and the last 120 kilometer in 1.5 hours. Calculate the average speed during the... Okay, what do we mean by the word average? It means that if we take the first speed and the second one and the third one, we have here the average speed for it. This means that the average speed means total distance that covered by the body divided by total time to cover this distance. Okay, we will calculate the first one as usual. Speed of the first time. We have here first 150 kilometer speed, v equal distance over time, or v equal d over t. So we have 150 divided 1.5 equal 100 kilometer per hour. The second one, 180 kilometer. We have here speed equal 180 divided 2 equal 90 kilometer per hour. The third one, we have here 120 kilometer. We have v equal distance over time, 120 over 1.5 equal 80 kilometer per hour. So the whole trip means that total distance divided by total time to cover this distance, 150 plus 120 plus 180 divided 1.5 plus 2 plus 1.5 all the time equal 450 divided 5 equal 9 kilometer per hour.